Now we'll go for second question. Consider a relation R. Okay, so he given attributes A to F, six attributes, and FD. Okay, so he given four FDs: A to B, C to DE, sorry DF, so AC to E, D to F. List the key and highest normal form of R. Okay, so he's asking highest normal form also. If it is not in 3NF, find the decomposition that is lossless and dependency preserving. Okay, so he's asking us to derive 3NF with these two conditions, that is a decomposition should be a lossless and dependency preserving. Okay, so what is lossless and dependency preserving, still you are not studied. We'll study some algorithms are there, then again we'll come back for this one, but we'll see how to decompose this one into 3NF. Okay, if it is not there in 3NF, how to decompose in 3NF, we'll study it. So he given, so total six FDs, sorry, six attributes. Okay, so first one A, B, C, D, E, then F. Okay, total six he is given. Okay, then FD he is given, A to B he is given. So A to B. Okay, so this is first FD. Okay, so I'll write as a F1 here. Okay, then C to D. C to C to D F is there. Okay, so C to D is there. Okay, so C to F is there. Okay, so this is my functional dependency 2. Okay, FD2. Then AC to E is there. Okay, AC. Okay, A C AC to E is there. Okay, AC to E. So this is dependency. So from AC you can derive E. Okay, then D to F. Okay, so D, this is D to F be given. Okay, so this is my fourth FD. Okay, so four FDs he given. Now we have to check the candidate key. Okay, so here, so we can see same thing, that is candidate key for that. That is you can draw in just on a graph. Okay, so that is we'll draw as a E to B. Okay, first FD whatever he given, E to B, then C to DE. Okay, so here I will write D, so then F. Okay, so these two are dependent on C. Okay, so here I'll write C and C to D F. Okay, so this the second FD is over. Then AC to E. So AC, these two together we can derive E. Okay, so I'll write here in between E. So from A, okay, and C, both together I can derive E. Okay, so this is, then the last one for the D to F. So D to F. Okay, so this one we written. So here any node is there with incoming degree as a 0, that is A is there and C is there. Okay, so both are part of our candidate key, so both together we can form a candidate key, that is A and C together. Okay, so we'll write here candidate key. Okay, so that is nothing but A and C both together is our candidate key. So here so only one candidate is key is there, so I will underline these things only. So this will form my primary key also. Okay, same thing, so I am considering as a primary key. Okay, so that is A and C both together. Okay, both together is my candidate key, sorry, candidate key and primary key. Okay, so now next is key we identified, then highest normal form. Okay, so highest normal form, that is AC both together. So we have to check it is there in which normal form. So by default it will be there in 1NF, so I'm writing here 1NF. Now we'll check it for 2NF. Okay, so any partial dependency is there on a primary key, it means it is not there in 2NF. Okay, so if you saw here B, there is a non-prime attribute. B is dependent on, partially dependent on A. Okay, so A is a part of our primary key, so it's depends on A. So that's why this is not there in 2NF. So whatever given R, Okay, so relation R, whatever he given, so it is not there in 2NF. Okay, so which violates is that is nothing but F1 violates, that is FD1 it violates, like that any other FDs are violating. So here these two deriving this one correctly, no problem. Okay, C2 D and F is there. Okay, so this is also partial dependency. So FD2 also violates. Okay, then D2 F. So is it violating? No. Okay, it's not dependent on, partially dependent on primary key. So this is something else only. D2 F. It's independent of our partial part of our prime attribute. Okay, so only f1 and f2 violates it. So we'll write that one, that is we'll say as a here this r. Okay, so in this f1, okay, then f2, okay, so violates the 2NF. Okay, so now we have to derive this one. Okay, so now we have to derive it to the 2NF. So whatever partial dependency is there, that we have to remove it. Okay, so here first what we are doing is whatever FTs are not violating, that just I will try to keep in same thing. Okay, so here first one, this one AC, so both together I will try to keep in the same one, AC to E. Okay, so it's the third FD, so I will keep as it is. Okay, so third FD here will keep as it is. So here these two together is the primary key. So, and it's pointing to E. Okay, so here F3, third functional dependency. Okay, then we'll whatever violating, that is A to B. Okay, so here we'll remove it. Okay, it is A to B, we'll write it. So A, okay, so to B, I will write it here. A is my primary key, I will make it. Okay, so this is F1. Okay, so this is my T1 table, so this is my second table, T2 table. Okay, then T3 table, so that is F2 is violating, that is C, D and F. Okay, so these things I have to write it. Okay, so these written in one single table, T3. Okay, so C two dependency, that is D and F. Okay, so this is what we written. So this is my F2. Okay, then F4, that is DF. Okay, so DF are there in this table. So here I will write it DF. Okay, so this is my F4. Okay, now we'll check. So this is a decomposition, R we decompose it into this T1, T2, T3. Okay, so now we'll check this is there in 2NF and 3NF or not. Okay, so here this is non-prime attribute E is fully functional dependent on primary key AC. It's there in 2NF, no problem. So here B is non-prime attribute fully functional dependent on A, no problem. Okay, so here non-prime attribute D and F are fully functional dependent on C. Okay, this if this is this is fully functional dependent. So this is not a problem. So all three are there in 2NF. So what about 3NF? We'll check it. So the transitive dependency should not be there. Okay, so E is completely dependent on AC only. We don't have any transitive dependency. So here B is completely dependent on A. We don't have any transitive dependency. And here if you saw, so F is dependent on D. Okay, and D is dependent on C. So there is a transitive dependency. That is, so whatever is there, this is a transitive dependency is there in F4. Okay, so F4, so this is violating 3NF. Okay, so we have to remove this one. Okay, so only this table I have to decompose. Okay, so these two will remain as it is because it's there in already 3NF. Okay, now this is violating the 3NF, so we have to remove that one. So that is F4 violates, okay, violates 3NF. Okay, so you have to remove that one. Okay, so after removing that, is you have to decompose it. Okay, so now whatever I will write it is two table, that is C to D, one table will form it. Okay, so C to D, one table will form it. So C will be the primary key. Okay, and second one more table will write it, so that is D to F. Okay, so here that is D to F, will write it. that is f4. Okay, whichever was violating, so we remove that one. So here this is f2. Okay, c to d is there, that is because of f2. So we'll write as this here. D is the primary key, and t3 we decompose it into two tables. So I'll write this one as a t3a. Okay, so this is t3b. Okay. Now we'll check is there in 2NF. Sorry, 2NF by default will be there. Now we'll check is there in 3NF or not, because it was violating 3NF, so we remove that one and we return this one as a in 3NF. Okay, so here three transitive dependency is there. No, here also transitive dependency is there. No, so this entire R we decompose into total four. Okay, four tables, that is T1, T2, T3A, T3B. We did it. Okay, so that is what all things we did. That will write it first. R was there, that we decompose into, okay, T1, decompose into T2, decompose into T3, then we decompose this one into, okay, that is T3A, okay, then T3B. Okay, we decompose it. So here we kept as it is T2, we are not changing anything. Okay, so here also we kept as it is in the final result, so T1 as it is. So here R was there in, okay, 1NF. Okay, so initially it was there in 1NF. So when we decompose into T1, T2, T2, so it was there in 2NF. Okay, then it was violating, T3 was violating 3NF. Okay, so entire decomposition was there in 2NF. Okay, see, although T1 and T2 are there in 3NF, but entire this row, whatever is there, there is a entire decomposition was there in 2NF or not, that you have to say it. Okay, so here it was there in 2NF. It was not there in 3NF. Okay, now this entire row, okay, so this is there in 3NF. Okay, yes, so all tables what is there in 3NF. So this is our result. Okay, so that is R we decompose initial into T1, T2, T3, then T1, T2, then T3A, T3B. Okay, so now this is there in 3NF. Okay, so this is the decomposition we have to do it. Okay. Then we'll go for next question. Okay. Consider R. Okay, so attributes given A, B, C, D, E, F, and FDC given. Okay, 1, 2, 3 FDC given. Then he's asking you to show that AD to F we can derive it. Okay, so you have to show the step-by-step procedure how we can prove as a AD attributes together we can derive the F. Okay, now in given these things we have to check anywhere I can get this thing or not. Okay, so AD to F. Okay, F is there here, right hand side. So here it's not there. Okay, so F is there in this FD. Okay, so here D is there. Okay, only I have to bring here A. Okay, that is AD will become here, this side F will become. So our result will serve that one. Okay, so that is our main purpose. Okay, so AD to F, I have to get it. So this one only somewhere I have to modify, instead of C I have to get as a here. So by default I will give the AD to F here. Okay, then here what we'll do is, we'll see there is a, we had as a CD to EF is there. Okay, so given, okay, CD to EF he given. Okay, so from this I can derive, that is this CD to F. Okay, so this is decomposition inference rule. Okay, IR4 whatever we had. Okay, so IR4 decomposition rule. Okay, here decomposition rule we had as a x to yz. If it is there means I can say x to y and x to z. Okay, so here two attributes are there, there is a two set of attributes, just I am dividing it. Okay, so same thing here, my x is nothing but, okay, so here my x is nothing but cd both together. Okay, and here this is e is nothing but y, f is nothing but z. Okay, so now cd to E only, that is will one will come, and CD to F one more will come. Okay, so I don't require CD to E, so I require CD to F. So this is what I'm getting it. So this one I got it from IR4. That is the inference rule 4, decomposition rule. From that I got it. Okay, then so here just my intention is, instead of C I have to bring the A. Okay, so for that what I will do is, here one more if we saw here. Okay, so here given as a A to BC is he given. Okay, same inference rule again I can apply IR4. So there I can get as A to C. Okay, so that is nothing but here I will see. So one more given. Okay, so this is also given. From that we derived this one. So again one more thing given is, okay, that is we have as A to BC. So it's the first FD he whatever given to BC. From this I can derive, okay, so A to C. Okay, so this is also we got it from IR4, that is a decomposition rule. Okay, we got it. Now, if we saw one more rule, we have, okay, transitive rule, pseudo transitive rule. Okay, so here, okay, pseudo transitive rule. Okay, so x to y, okay, if you have, and wy to z if we have, okay, so and then we can, what we can do is just wx we can do it. So instead whatever y was there here, x to y whatever was there, okay, so y whatever was dependent, that I can remove it. Okay, so I can put it that one. Okay, so x I can put it, wx can derive z. Okay, so like this it is there. The same thing what I will do is c to d is there. Okay, but c is dependent on a, so instead of c, so I can put a there. Okay, that is by these two things there is a consider as here I will make this equation number one. Okay, so this is equation number two. Okay, so from equation one and two, okay, so from equation, okay, one and two, from equation 1 and 2, okay, and applying, okay, so IR6, that is inference rule of pseudo-transitive. Okay, so IR6 if I applied, so what will happen? So A to C, C to sorry, A to C, CD to F, whatever was there. So C I can remove it, then I can put as a E there. So this will come as a ED to F. Okay, so this is a ED to F. So whatever he asked for, that one only ED to F. Okay, so while explaining whatever things we get told here, just one line explanation you have to give it. So what is that IR4? Okay, is here, and what is IR6? So then we are getting this one. Okay, this is pro transitive rule. So this is what we are getting the our result. Okay, so we derived whatever he asked. Okay, so it is, so from given FDs I have derived as a ED to F.